Hi, today we'll talk about redo files in Oracle. Redo files is a part of the physical structure of the database. It's physical files which sits on the disk. So if you look at the phys- database architecture diagram, you'll see the redo files, data files, and control file primarily makes the physical uh, structure, and redo files it sits on the disk. So why do we need a redo files? What is the purpose or roles of redo files in the database engine? So anytime you do an update to any data, so you try to look for the data or that database block which contains that row in the database buffer cache, which is in memory. So let's say you are updating the salary of one employee ID. So you look for that employee database block which has that employee record, the employee ID equal to 101. So if you, as you know, Oracle does all its operation in the block size. So anytime it wants to read a record or update a record or delete a record, it will read that entire block from the disk and put it in the buffer cache. So it'll read from the data file, the disk, it block. It doesn't read just one row at a time. It reads entire block. And the standard block size is 8 KB, like 8,000 bytes. So that means one block can contain many rows. For example, so if I look for employees, so it has like, let's say one character is 1 byte. So it is 20 bytes, 25, 25, 20. So let's say this is like around 100 bytes. And this comes less than 100 bytes. So let's say the total one employee record is maximum is like 200 bytes maximum. Like if you fill that each row to the capacity, maximum limit capacity, it will contain like 200 bytes. That means one database block, which is 8,000 bytes, will we contain can hold up to 40 records, 40 employee records. So if you want to read one row or update one row, but Oracle reads the entire block from the data file to the buffer cache, and then it does all the operation on the memory. Oracle doesn't do any operation on the disk, so it will copy one block just to update one employee record, copy the entire block to the database buffer cache, and then the server process. The server process works on the behalf of the user. The server process will update that record, each record, and then it will not, when you do a commit, it doesn't write the block back to disk, because the update now happened only on the memory. If there is an instance crash, you lose the data. So you need some way to save the data back to the disk. So in case there is an instance crash, or there is a memory crash, you don't lose the data. But Oracle doesn't write the entire block from memory to the disk. It will be like huge IO. It will slow down the database drastically, because for every update, every record update, if you want to write 8 KB block back to disk, it will make the database very 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 slow. So instead of that, what Oracle does is Oracle uses online redo log files, redo log buffer, and online redo log file. Redo log file is also on the disk, but instead of writing the entire block or the entire employee record to the disk, it writes only the change vector. That means only the minimum information that is needed to recreate that change. Only that minimum information it writes to the disk, which is in the read log file. So it will write it every time, anytime you update the record, it will update the block, the record in the buffer database buffer cache. Also, it will write the change vector, the minimum information needed to recreate the change. For example, if you are updating salary for one employee ID, you just need the primary key, which is the employee ID, and then the salary before the change and salary after the change. Only this much information you need, which is like maybe 20 bytes information. It's not 8,000 bytes, it's now 20 bytes. So that information it will write to the redo log buffer. Now redo log buffer is also in the memory. We have to write to the disk, to the redo log file. So that happens when you do commit. Anytime you do a commit, and before you see the commit complete message on your screen, log writer writes that redo log buffer, that change vector to the redo log file. So when you see the commit complete message, the change information is already saved to the disk. This is Oracle way of ensuring or giving a guarantee that when you save your data to the database, it cannot be lost. No matter what happens, if the instance crash, database crash, you can still recreate the change and recover the database. Unless, of course, you go and drop your database or delete your data file and delete your backups and delete your redo log files. Of course, then you cannot do anything. But in normal, unexpected any kind of problems and error outage, Oracle ensures that it can recreate the change and your data is safe. It's called the durability. Your data that you have in the database it's durable. It's not going to get lost. So that's the purpose. So the redo log file is very important, and it's needed for the data safety and recovering the database. That's the reason Oracle recommends having multiple copies of online redo log files, which is called multiplexing. So if you look at here, this is the redo log buffer, and this is the log writer is writing to it, and there are two copies of it. So Oracle also recommends keeping this multiple copies in separate disk. So in case there is a disk failure, and if the failure is local to one disk, you have one more copies in other disk. And the log writer automatically takes care of writing the redo log data into both the copies. You don't have to manually do anything to make sure that the data is written to multiple copies. Log writer will take care of it automatically. And this each one is called redo log group. This is redo log group one. This is redo log group two. And each group has two multiple copies called two members. It has two members. And these redo log files have some maximum size, file size. It's like 500 MB, 200 MB, or 1 GB or 2 GB. You can set any maximum file size. So once the file is full, Oracle has to switch to the next file. So you have multiple groups. So in this case, here I have three groups: group 1, group 2, group 3. So it will write to group 1, and once it is full, then it will start writing to the next one. It's called log switch. It's switched to the next log file, and every time it's do a log switch, go to the next file, it creates a next log sequence number. So as you can see, there's a number here, 1, 2, 3 is a incremented to the next number every time there is a log switch. And so once all the groups are written, let's say it writes to group 1, then it goes to group 2, then it does a log switch again, it goes to group 3, and then it comes back and override the redo log group 1. So if your archiving is on, because this is change information is very important for recovery purpose, for production environment, you want to keep these changes, back up these changes and keep it as a backup for long-term use before it is overwritten. That is called archiving. You just have to turn on the archiving, and Oracle will take care of it automatically. Oracle will take care of taking backup. It will ensure that this group is backed up or archived before it is overwritten. If it's not overwritten, Oracle will wait. That's also another wait event. So there is also a command to manually switch to the next log file. One is Oracle will automatically switch the log file from 1 to 2 once the file 1 is full. But there is another way of doing a manual log switch. If you want to switch to the next two, you can do. There is a command called alter system switch log file. We'll see those in 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 the screen. Let's look at the database and see all these things in action. So, there are two views called $log and $log file. This is from $log. I'm selecting group number. So they have three groups, one, two, three. And this thread is used for cluster database. So I have only one instance, so I have thread one. If you have another instance in a cluster database, so that will be thread two and group will be four, five, six. That may. And sequence number, as I mentioned, that every time there is a log switch, it generates a new sequence number. So you can see there's a one log sequence 106, then 107, and now it's one latest one is 108. And this is the file size. Each group file is 200 MB size. After the 200 MB data is full, it will switch to the next log group automatically. And this is the block size and members. As I mentioned, Oracle recommends to keep multiple copies of it called multiplexing. And each file is called the member of the group. So as you can see, each group has two member. And archiving, I mentioned, like before it overrides, you need to archive it. So for my database, archiving is on. So this two database archiving is done, yes, and the third one is pending. And the status is inactive. Only thing remember is if it is current, that means the log writer is currently writing to it. As you saw in the diagram, the log writer is currently writing to redo log group one. So group one is now current. The group to group three can be active or inactive status. So we'll see shortly what is those active and inactive means. Before that, let's look at $log file. $log will give you the information about the $log groups. $log file will give you information about the individual member. So if you select this, you can see each group each group has two member, two file. And this is the file location. Online is this type can be online or standby. If it is standby database, you will see standby here. And each group has two member. And these are the location. It's redo 01, redo 01A, 22A, and 33A. Now, let's look at the active inactive. So what happens is when Oracle is let me see if I have a okay. So what happens is Oracle is writing to this, right? So let's say this is my log file, okay, and this is my log writer is writing to it, and this is my log groups, and log groups is a circular buffer, so it keeps writing to it. Whenever there's an update, the change information will be written to it, and it'll keep writing to it. Everything is done, then it'll go to the first slot. It's called divided into different segments, so it will write as a circular buffer. So once this is full, it will go to the next one. It skips overwriting it. So this is my redo log file. So this is a log writer, and this is my redo log. So it keeps writing to it now, and this is my, let's say, data file. So the data I have, and this is a block, for example. So I have written this block to the database buffer cache, and then the database buffer cache, I made the changes. I changed the salary. Now the salary information, the new information is in the log writer, but the data file is still is having old salary information. Any session wants to select that employee record and get the salary. Oracle will get it from the memory. It is already there. The updated information it will read it. But in case there is this instance crash, the data file has old information. So next time when there's a instance starts, the Oracle will take care of recreating all the changes and apply all the changes to the data file and then recover it. It's called instance recovery and bring it up to the mark. But if there are a lot of changes in the redo logs pending to be applied, and there is a database crash, when the database starts up next time, the recovery might take a lot of time. So Oracle doesn't really wait for instance crash or anything. It keeps from here, it keeps writing whatever changes has been written to log writer. So these are the changes written to redo logs. It keeps updating the data file, not from here by the way, but from the database buffer cache. There's a process called checkpoint. Checkpoint signals a DB writer to keeps writing the updated data from, it's called dirty blocks, from buffer cache to the data file. So that this there are not lot of data changes pending to be applied to data file. So checkpoint keeps track of till what point it has been applied, let's at this point. So whatever changes after that, after some time, it will signal the DB writer, so that all the next set of changes, like this much changes, it will signal the DB writer to sync the data from the memory database buffer cache to data file, and it'll keep a mark that okay, up to this point everything has been applied to data file. So next time there is an instance crash, Oracle will start the recovery from this point, because this point already applied. This way Oracle ensures that if there is an instance crash and the instance recovery doesn't take a lot of time, so the database can recover quickly. And also it also ensures that there are no, because log writer is going to override, as I mentioned here. Once the redo log group 3 is full, it will go and overwrite. So before it is overwritten, I need to sync all these changes to the data file, because data file is out of sync now because I'm not writing to the data file. So checkpoint does that operation. It's called checkpointing. Checkpoint keeps track of, it's called RBA, redo byte address, up to what RBA the data has been written. And the data has been written to the data file. Then after a few seconds, it sees that it is out. It needs to sync a little more, so it will signal the DB writer. The DB writer will write from database buffer cache to the data file, and then it will move to the RBA here. So next time there's a crash, Oracle will will recover only from this point. So as long as all the data has not been synced to the data file, this file is needed for instance recovery. And when it is needed for instance recovery, the status here is active. Once all the data has been, all the changes in this redo log file, let's say this is redo log group 1 and there's a redo log group 2. So with all the, and let's say log writer is writing to group 1, now there's a log switch, it is switched to 1, is writing to 2. Let's say I have only two groups. So after two, it will come back to one again. So before it can come back again, I need to write everything, whatever is there here, I need to sync to data file. Otherwise, log writer cannot switch, it has to wait. So that is another one more purpose why Oracle has to keep writing this all the changes back to the disk. It cannot keep it in redo log file for very long. Sometimes the redo log files are like 1 GB, 2 GB also for very large database with high volume of transactions. So imagine if you don't do this and this entire file is pending for recovery and there's an instance crash. Now Oracle has 1 GB of worth of data to sync to the data file. It might take a lot of time to next time when the database you start the database, the recovery might take a lot of time. And you might be as a DBA wondering why the database is taking so long time for startup. It also affects the recovery time objective RTO, and there are some business SLS for recovery. So that's the reason. And when this file is needed for recovery, that means all the changes has not been synced to the data file. This status is called active. Once everything is written, it's called inactive. So the data file can, so the log writer can switch to a redo log groups once it is inactive and archived. So if you can see here, it is inactive and it is archived. Only now, if I do a alter system switch log file, as I said, that's the manually I'm doing a force switch log file. Switch log file. Now, if I look at the redo log groups again, now I can see 108 was current, 108 was current, 106 was inactive. Group 1, it was group 3 was current, group 1, 2 was inactive. Now, group 1 is current, has moved to group 1, is switched from 3 to 1. Now, 3 is active. Because the changes that is there in group 3, it is not yet synced with data file. This file is needed, this group is needed for recovery. In case there is a database crash, this because this has some unsaved changes needed for recovery. In case there is an instance crash, Oracle will use this file to recover the database. It will do automatic recovery. You don't have to do anything. And also see the archives. No, it's not an archive. If I do alter system switch log file again, then it will go from group 1 to group 2. And if I do one more time, it will go from group 2 to group 3, provided it is inactive and archive is yes. If not, it will wait. So let's run this again from $log. Now you can see it is active, but its archiving is done, but still it is active. If I do a alter system switch log file again, I did it one more time, so it has to go from group 1 to group 2. So if I check $log, I can see group 2 is current, group 3 is active, still this file is not all changes has been written to the file. So one thing I wanted to show you that now you can see my group 1 is active, group 3 is active, group 2 is current. So if I do a switch log file again, it has to go to group 3. But group 3 is active, so the alter system, the switch log file might hang a little bit. We're waiting for Oracle to make that redo log group active from active to inactive. It's already archived. You can see it's already active, archived, but it's only active. So if I run it again, see it is hanging a little bit. It's waiting for Oracle to change from active to inactive. So that's about redo log file. Thank you. Bye.